The next stage is to install the landing gear. These massive parts have to be unbelievably strong. Not only is the A380 the biggest passenger plane ever built, unfortunately, landing gear in general takes a terrific pounding in the real world. Most landing gear engineers have this low-resolution video clip on their computers, a reminder of the extreme conditions that can occur. Heading for the now disused Kai Tak Airport in Hong Kong is a Boeing 747. Approaching in a crosswind, the left-hand gear takes the full weight of this huge plane as it hits the tarmac. That such a difficult landing can be successful, as this one was, is an amazing feat of engineering. That gear was made by the Goodrich Corporation, who are also supplying the main landing gear for the A380. Here, near Toronto in Canada, production is well underway, and testing is just about to begin.
When we have a new landing gear program, we have a lot of tests that we need to do. Strength, performance, dynamics, durability. This one is a performance test. This is one of the first tests we do. It's one of the more important tests. It's called a drop test. What it is a simulation of landing. So when an aircraft lands, an A380 lands, 560 tons of aircraft moving slowly towards the ground, as well as 200 miles an hour down the runway. When the aircraft hits the ground, something has got to absorb that energy. So if you jump off a chair and you land, your knees have to bend and give a little bit. Even just with the weight of a person, you're going to damage yourself if nothing gives. So that giving of your knees, your legs are absorbing energy. That's what the landing gear has to do, but it has to do it for, instead of 180 pounds, it's got to do it for 560 tons.
Suspended inside this huge tower, the landing gear is raised in preparation for the drop. The rig is static, so to simulate the approaching ground speed, smaller wheels driven by powerful electric motors spin the big 55-inch tires in the reverse direction. When a switch is flicked in the control room, a hook at the top of the tower will release, allowing the gear to fall. It must absorb the same energy as a 100-mile-an-hour car crash without being damaged. It's a critical phase in the whole program.
This could be a make or break test. If the performance of the landing gear isn't what we predicted it to be, it could impact the schedule for the first flight. So it's essential that the gear performs to how we predicted it. And from these tests we'll be able to tell whether it does.
Soon they'll find out if their latest and largest landing gear will make the grade. Although it's huge, this 6.5-ton component is just part of the A380's undercarriage. In total, it will have 2 6-wheel units, plus 2 4-wheel units under the wings, and a 2-wheeled set under the nose. So what you're about to see is only a fraction of the energy involved when the vast machine touches down.
Okay, I'm going to drop now. Oh, it's too hot.
Just the delay, you can see it moving here.
Oh.
All right.
The test goes well. Early data shows that although there was an unwanted shudder as the wheels came to a halt, the landing gear shrugged off the huge impact with ease.